We've already been able to use ratios to find side lengths in special right triangles, but for any other kind of triangle, we're going to have to use trigonometry. And that means if we know certain combinations of side lengths and angle measures of a right triangle, we can use ratios to find the other side lengths and angle measures. So still looking for missing sides and angles. Any two right triangles that have a pair of congruent acute angles are similar by angle-angle similarity. Again, that just means I need two angles to match from one triangle to another. That means they'll be similar. Similar right triangles have equivalent ratios for their corresponding sides, and we call these the trigonometric ratios. So the trigonometric ratios are the ratios of two sides of a right triangle. Those three that we're going to be using are sine, cosine, and tangent. Those are your three basic trigonometric ratios. So looking at those three, if I say to take the sine of an angle, so the sine of angle A, and angle A would be down here, that's going to take the ratios of two sides, the length of the leg opposite A, divided by the length of the hypotenuse. So that's the opposite over the hypotenuse length. And in terms of this figure, that would be A over C, because A is opposite angle A, and C is that hypotenuse. If I want the cosine of angle A, so still starting from this angle, cosine, I take the length of the leg adjacent to A, so that would be this leg, B, and I divide that also by the hypotenuse. So cosine would be adjacent over the hypotenuse. And for tangent, our third function, that means I'm going to take that opposite first again, so the length of the leg opposite, which is A, and then instead of the hypotenuse, I'm going to take that over the leg adjacent to A, which is side B. So tangent would be A over B in that situation. If we want to abbreviate those three ratios, again, sine, that was opposite leg over hypotenuse, so opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent was opposite over adjacent. And if I want to remember those three, really common, you'll see this acronym, SOHCAHTOA. The SOH stands for sine is opposite over the hypotenuse. The CA part of that, so stands for the cosine. C stands for the cosine, A for adjacent over hypotenuse, and for the tangent, that's opposite over adjacent. So one more time, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, SOHCAHTOA. So if we're going to use SOHCAHTOA in this example, we have to use that to find sine, cosine, and tangent ratios, all using angle t. So sine, again, if that's so, O over H is opposite over hypotenuse, so 8 over 17 would be the sine. The cosine, still starting from that angle, would be adjacent over hypotenuse, so that's 15 over 17. And tangent would be opposite over adjacent, so that's 8 over 15. And we can take it not always from the same angle, so let's say instead if I want to use angle G, the sine now, 15 is the side opposite, so that would be opposite over hypotenuse. So sine would be 15 over 17. Cosine would be adjacent over hypotenuse again, but now the adjacent is 8, so 8 over 17. And tangent pretty much just flipped because opposite and adjacent changed. So tangent from G would be opposite over adjacent, that's 15 over 8. And we can also use a calculator to find these, and this is if we're given an angle measure. If I want to find the sine of 52, and these we'll get practice with, and you need to ask if you have trouble working your own calculator. Each one's a little bit different. But if we're going to find these in the calculator, we want to always make sure it's in degree mode. We're not using radians for these angles. But if I'm trying to find the sine of 52, you can try to see how to enter that in your calculator. You should get 0.79. Cosine of 19 degrees should give you 0.95, and tangent of 65 will give you 2.14. If you can't get those, you need to be able to ask and see how to get those come up on your own calculator. So let's try and use sine, cosine, tangent to find some missing lengths. And in problem 1 here of finding W, trying to find that just by knowing this angle and the hypotenuse. So looking at the angle that we're given, this 54 degrees, the variable's on the side that's opposite, and again we're given the length of the hypotenuse. So if I think opposite and hypotenuse, we want to be thinking sine. Again, if I think of SOHCAHTOA, the opposite and hypotenuse was the first part of that, so gives us the sine function. So sine is opposite of hypotenuse, and if I want to set that up, that's saying that the sine of this angle, sine of 54, is opposite over hypotenuse, so sine of 54 is W over 17. And if I want to solve that for W, instead of dividing, I want to multiply both sides by 17, so I get 17 times the sine of 54 is W, And if I enter that on my calculator, 17 times the sine of 54 degrees, I should get about 13.8. So next example, this time I still have an angle and two sides, one which I'm trying to find and one which I already know. If I look at the angle that I start with, the variable is the adjacent side, and I'm given the opposite side. So if I'm using those pieces, opposite and adjacent, I want to be thinking tangent. That TOA part is opposite over adjacent. So if I set that up, the tangent of this angle, tangent of 28 degrees, is opposite over adjacent. So that's 1.0 over W, or we could just write 1 over W. And if I want to solve for W, what we have to remember here is that if it's on the denominator, I'm going to have to isolate so that W is by itself on the numerator. I can multiply both sides by W. That'll get this denominator to cancel. And I get W times the tangent of 28 degrees is equal to 1. And if I'm ever trying to isolate for W, so if I want to move this tangent of 28 degrees, I can't just divide by 28. This tangent of 28 degrees, you want to think of as an expression that has to stay together. So instead of just dividing by 28, I divide both sides by the tangent of 28, and that gives us that W is equal to 1 over tangent of 28. And this, again, we can just punch into the calculator. 1 divided by tangent of 28 degrees should give us about 1.9. And last practice question there. Looking at our pieces, we start with this angle, and we want to find the side that's adjacent, and we also know the length of the hypotenuse. So adjacent and hypotenuse, we want to be thinking cosine. So cosine of 33 degrees is adjacent over hypotenuse, which is W over 4.5. And just like the first practice problem, I can just multiply both sides by 4.5 and enter this 4.5 cosine 33 into my calculator. Should get about 3.8. So last question here on this page is talking about same situation, but now it's put into a word problem. So we drop an object from the Leaning Tower of Pisa and drops a height of 150 feet. The tilt of the tower is 5 degrees, so that would be that angle listed at the top. And we want to find how far from the base of the tower will the object land. So our variable, how far from the base of the tower will it land, is basically that base of the triangle. And looking at my pieces again, I have the angle up here, and it looks like I'm looking for those two sides. So if the two sides, I want to find the side that's opposite, and I'm given the length of the adjacent, if I think opposite and adjacent, I should be thinking tangent. So the tangent of 5 degrees is opposite over adjacent. That would be x over 150. And again, if I just multiply both sides by 150 and punch that into my calculator, I should get about 13.1 feet. So most important step I'd say is make sure you have the right trig function. If I'm using opposite and adjacent, I could do all the same work, but accidentally use sine. Not going to end up with the right answer. So that would have to be tangent. So last page, if we know the sine, cosine, and tangent ratio for an angle, we can use an inverse trigonometric function to find the measure of an angle. So those three inverse trig functions, we're going to use sine, that little negative one, as an exponent. It means we're taking the inverse of that. So we read this as inverse sine, inverse cosine, and inverse tangent. So these three we're always going to be using if we want to find an angle instead of a side. So these will also be in your calculator. Usually it'll be some kind of a second or shift function, but again, each one is different, so make sure you know how to work yours and ask me if you need help. But the inverse of cosine of 0.87, if we punch that in, rounded to the nearest degrees should give us 30 degrees. Same thing, the inverse sine of 0.85 should get us 58 degrees, and the inverse tangent of 0.71 should give me 35 degrees. So again, we're always going to use an inverse trig function when we want to find an angle instead of a side. So if we are finding the measure of angle x to the nearest tenth of a degree, first thing we want to decide is what trig function we're using. If the two sides we're given are the side that's opposite of x and also hypotenuse, opposite and hypotenuse should be the sine function. So if I set that up, sine of x equals opposite over hypotenuse, that'd be 6 over 10. And remember, if I'm looking for an angle, instead of the sine, I want to use an inverse sine, because the missing measurement is an angle measure. So the inverse sine of 6 over 10 should be 36.9 to the nearest tenth. Same thing on number 2. This time, if I still want to find angle x, this time I'm given the side that's adjacent, not the opposite. So adjacent and hypotenuse should be cosine instead of sine. So if I set that up as the cosine of x is 15 over 20, adjacent over hypotenuse. Same thing, since I'm looking for an angle, I want to use an inverse cosine function. So inverse cosine of 15 over 20 should get us about 41.4. And last question, also using tangent. If I want to find the measure of angle y, I'm using tangent because I'm given the opposite and adjacent. So basically, whenever we're not given the hypotenuse, it's always going to be a tangent function. So the tangent of angle y, opposite over adjacent, is 100 over 41. So if I want to find an angle measure, we have to remember to use an inverse trig function. The inverse tangent of 100 over 41 should come out to about 67.7. So let's also answer this last question. If we know the lengths of all three sides of a right triangle, would it matter which ratio we use to find any of the three? And the answer there would be it wouldn't matter, because if you know the opposite, if you know the adjacent, and you know the hypotenuse, you really should be able to use any of the three trig functions. And should solve that lesson check. I'm going to check and see how we did on those when we look at that in class together. But go ahead and see if you can solve those problems using what we just learned in the notes.